Good morning, students. Myself, Dr. Ragasudha, Head and Assistant Professor, Department of Microbiology, Government City College, Hyderabad, is here with a new topic on electron microscopy. History of electron microscopy. In 1897, J.J. Thomson discovered the electron. In 1924, Louis D. Bogley identifies wavelength for electron. In 1929, E. Ruska has thesis on magnetic lens. In 1931, Knoll and Ruska built the first electron microscope. In 1938, von Boris and Ruska built the first practical electron microscope. Electron microscope uses a beam of highly energetic electrons to examine objects on a very fine scale. This examination brings the details about the observant. It gives the observant about the topography, morphology, composition, and crystallographic structure of the object. Electron microscopy provides magnification 100 times more than that of the light microscope. It uses electron beam and magnetic fields to produce the image, whereas light microscope uses light waves and glass lenses. Much higher resolution is obtained with extremely short wavelength of the electron beam. The principle behind electron microscopy is it employs 60 to 80 kilovolts electrons. The wavelength is only of 0.05 angstrom. 1 angstrom is equal to 10 to the power of minus 8 centimeters. It resolves objects as small as 10 angstroms and produces a magnification up to 4 lakhs. Methodology behind electron microscopy. The specimen to be observed is prepared as extremely thin dry film on small screens. These are then introduced into the instrument at a point between the magnetic condenser and the magnetic objective. The magnified image is viewed on a fluorescent screen through an airtight window. The image can be recorded on the photographic plate by a camera built into the instrument. There are two types of electron microscopes: scanning electron microscope and transmission electron microscope. Scanning electron microscope focuses on the sample surface and its composition. It scans a gold-plated specimen to give a 3D view of the surface of an object, which is black and white. Use it to study surface features of materials, cells, and viruses. Scanning electron microscope has a resolution 1000 times better than the light microscope. Image of a scanning electron microscope. Working of scanning electron microscope. The electron gun produces an electron beam which is accelerated by the anode. The beam travels through electromagnetic field and lenses, which focuses the beam down towards the sample. A mechanism of deflection coils enables to guide the beam so that it scans the surface of the sample in a rectangular frame. When the beam touches the surface of the sample, it produces secondary electrons, backscattered electrons, and X-rays. The emitted secondary electrons, or SE, are collected by secondary electrons detector and converted into signal that is sent to a screen which produces the final image. Diagram of scanning electron microscope. In the diagram, you can see electronic gun consisting of cathode and anode, followed by condensers, first condenser lens and second condenser lens. The condenser lens controls the amount of electrons traveling down the column. The objective lens focuses the beam into a spot on the sample. Deflection coil helps to deflect the electron beam. SED, secondary electron detector, attracts the secondary electrons. Additional sensors detect backscattered electrons and X-rays. These are another two structures of scanning electron microscopy with their different parts. Image of scanning electron microscope. for Vibrio coloring, where we can see the polar flagella of the Vibrio coloring. And this is another image produced by scanning electron microscopy. It is different types of bacteria present on the surface of a human tongue. Advantages and disadvantages of scanning electron microscope. Advantages. It gives detailed 3D and topographical image and the versatile information garnered from different detectors. This instrument works very fast. Modern SEMs allows for the generation of data in digital form. Most SEM samples require minimal preparation action. Disadvantages of SEM. They are expensive and large. Special training is required to operate an SEM. The preparation of sample can result in artifacts. SEMs are limited to solid samples. SEMs carry a small risk of radiation exposure associated with the electrons that scatter from beneath the sample surface. Moving on to the next type of electron microscopy, transmission electron microscope. It is used to see the fine structure of the cells. An object as small as 1 nanometers may be viewed. Ultra-thin sections of the objects are prepared by embedding or freezing the sample and sectioning it with a diamond of glass knife. Sections are floated in water and picked up on a wire gird. They are stained with heavy metals like gold or palladium to make certain part dense and insert in the vacuum chamber of the microscope. The principle behind the working of transmission electron microscopy is electrons possess a wave-like character. Electrons emitted into vacuum from a heated film with increased accelerating potential will have small wavelengths. Such high energy electrons can penetrate distance of several microns into a solid. If these transmitted electrons could be focused, image with much better resolution is obtained. Focusing relies on the fact that electrons also behave as negatively charged particles and therefore deflected by electric or magnetic field. A 1 lakh volt electron beam is focused on the section and manipulated by magnetic lenses. A photograph prepared from the image may be enlarged with enough resolution to achieve a magnification of 5 lakh to 10 lakh times at 1 nanometer resolution. The advantages of transmission electron microscope: it offers very powerful magnification and resolution. It has a wide range of applications and can be utilized in a variety of different scientific, educational and industrial fields. Transmission electron microscopy provides information on element and compound structures. Images are high quality and detailed. It bears even disadvantages like it is very large and expensive instrument, laborious sample preparation, operation and analysis require special training, samples are limited to those that are electron transparent. Transmission electron microscopy requires special housing and maintenance, images are black and white. This is an image of transmission electron microscopy with the different parts. Now let us see the difference between SEM and TEM. SEM is based on scattered electrons while TEM is based on transmitted electrons. SEM focuses on the sample surface and its composition, whereas TEM provides the details about internal composition. Therefore, TEM can show many characteristics of the sample such as morphology, crystallization, stress or even magnetic domains. On the other hand, SEM shows only the morphology of the samples. The sample in TEM has to be cut thinner, whereas there is no such need with SEM samples. TEM has much higher resolution than SEM. SEM allows for large amount of samples to be analyzed at a time, whereas TEM only small amount of samples can be analyzed at a time. SEM is used for surface, powders, polished or etched microstructures, IC chips, chemical segregation, whereas TEM is used for imaging of dislocations, tiny precipitates, grain boundaries and other defined structures in solids. In TEM, pictures are shown on fluorescent screens, whereas SEM picture is shown on monitor. SEM also provides a 3-dimensional image while TEM provides a 2-dimensional picture. TEM requires extensive sample preparation. The thickness of the specimens to be examined under TEM should be less than 100 nanometers of size. Thank you.